In this example here, again, what we're going to do is find where it's concave up and where it's concave down and any inflection points there might be. So we're going to see that this one shows us that the principle of finding it is not difficult, but it often takes a lot of derivative work. All right, so x times x minus 4 cubed. Right. So the first derivative, all right, I have a product. So I'm going to look at it as the product of x and x minus 4 cubed. Derivative of the first is 1 times the second as it is, x minus 4 cubed, plus the first as it is, then the derivative of the second, so I would have 3x minus 4 squared, and then the derivative of x minus 4 is 1, so that would be the chain rule part there. All right, so let me clean this up a little bit. X minus 4 cubed plus 3x x minus 4 squared. Now, I could go ahead and multiply that out before taking the second derivative, but I think I'll just factor first and try and see if I can clean this up a bit. So notice that each of these terms has an x minus 4 squared in it. So I'm going to take out x minus 4 squared, and I'm going to be left with x minus 4 from the first term, and then plus a 3x from the second term. So I get x minus 4 squared times 4x minus 4. Okay. So now I could factor out a 4 from that second part, but I'm going to leave it for now as I go to my second derivative now. All right, so all of this was the first derivative. Now I'm going to start doing the second derivative. Again, I'm going to look at this as a product. So the derivative of the first is 2 times x minus 4 times 1 for chain rule, times the second part as it is, all right, times plus the first as it is, x minus 4 squared, times the derivative of the second, which would just be 4. Now I'm going to pull out some common factors. I definitely have at least a 2 times x minus 4 common here, and that'll give me 4x minus 4 plus a 2 times x minus 4. Keep working on that. So that gives me, this will give me 2x minus 8. So this gives me a 6x minus 12 overall. And then finally, I will factor out a 6 from in here. So I get a 6 times 2, I get 12, x minus 4 times x minus 2 when I take the 6 out. Okay, there. All of this was getting the second derivative, but now I have it. Okay, so that was all just finding the second derivative. Now the rest should flow pretty nicely. Again, I have the second derivative. I want to ask, when is the second derivative 0? When is the second derivative undefined? Well, it's 0 at 4 and 2, and there's nowhere where it's undefined. All right, again, I'm going to go back and put together a chart. All right, so I'm going to put on this chart 2 and 4, and again, this is my second derivative chart. So let me put in some numbers less than 2 back here, and my second derivative. 12 is always positive, so then it just matters what happens to x minus 4, x minus 2. So if I put in, say, 0, I would get a negative times a negative, I'd get a positive. If I put in something between 2 and 4, say 3, I'd get a negative and a positive, I'd get negative. If I put in 5, which is bigger than 4, I'll get positive times a positive, overall positive. That tells me here F is concave up, here F is concave down, here F is concave up. Now I look to see what's happening at my important points here. So I look at 2, and I say, is there a change in concavity? Yes, it went from positive to negative. So that is an inflection point at 2 something. And over here at 4, it did change from negative to positive. So that is also an inflection point at 4 something. So again, I'd have to go back to my original function. So let me do a little space in here. My x and my y, which is f of x. So I'd have to go to my original function and use this to plug in. So I'd put 2 and 4. Right? If I plug in 2, then I get 2 times negative 2 cubed. So I'm going to get negative 16. If I put in 4, I'm going to get 0. So I have my inflection points as 2, negative 16, and 4, 0. And now I summarize. Concave up, concave down, and any inflection points. All right, it was concave up on negative infinity to 2 and 4 infinity. It was concave down on 2, 4, and we had inflection points at 2, negative 16, and 4, 0. That's it. There's the information I was looking for.